Hello everybody, and lesson 5. Let's talk about inorganics. Topic: glass. This topic deals with glass materials and glazing, which is widely used in building construction. Glass has been used for glazing for many centuries, as well as for bottle and containers, drinking vessels, and decorative objects. In the 20th century, the use of glass widened to include fibers for reinforced polymers, glass wool for thermal insulation, and following advances in electronics, the use of long fibers for fiber optic devices. So the chemistry and structure of glass is dealt with here, as well as the processes of glass making and the shaping and forming of glass into the various products used in buildings. Durability of glass is discussed, as well as the various problems that arise with the use of glass. While glass is transparent, it also has a low fracture toughness, and this brings problems in its wake. These problems and the ways in which they may be mitigated are discussed here, and we discussed on this in this lecture. The mechanical properties of glass, which make it useful as a reinforcement material for composites, and the production of fibers for this purpose are also discussed. Contents include introduction, general properties of glass, raw materials of glass, glass manufacturing, including melting, for example, pot, furnace, tank furnace, chemical reactions. The next subtopic: forming and shaping, annealing, finishing, type of glasses, and of course properties of different type of glasses. So, what is the glass? Glass is an amorphous, hard, brittle, transparent or semi-transparent, supercooled liquid obtained by melting a mixture of a number of metallic silicates, most commonly natrium, kalium, calcium, and plumbum. It possesses no sharp melting point, crystalline structure, and definite formula. Glass artifacts were first made in ancient Egypt and in Europe since the Iron Age. All these glasses were made from naturally occurring raw materials and contained a major percentage of silica. A glass-forming oxide. These earlier artifacts were vessels and containers of various types, with some being made for utilitarian purposes and other for artistic, decorative reasons. Today's glass is made for many purposes: glazing for building, containers, ovenware, for optical purposes, and for production of glass fibers, both for optical reasons and for the reinforcement of composites. Decorative and artistic objects are still made in large numbers. Glass is a hard, transparent solid at room temperature. Also, it's often described as a supercooled liquid and sometimes as an inorganic polymer. The important property of glass is its transparency, and it finds its use in building construction primarily for this reason. Glass is used in windows to admit daylight while keeping out the weather, and also retaining the internal heat of the building. Glass can also be given a lustrous appearance by the addition of lead to the mix, and so can be used to make attractive drinking vessels and containers. It can be colored by the addition of other materials, and there is virtually no limit to the range of aesthetically pleasant objects and works of art that can be made from glass. A visit to any Venetian gift shop will quickly confirm this assertion. So we already understand that glass represented as X, R2O, YMO, and 6 silica, and of course glass forming oxide. R equal monovalent alkali metals like natrium and kalium. M divalent metals like calcium, plumbum, zinc, etc. X and Y equal whole numbers. Approximate composition of ordinary glass, soda lime glass, is natrium 2O, calcium O, and 6 silica. So silica and glass forming oxide. In some glasses, silica may be replaced by aluminium 2 oxygen oxide 3. Silica may be replaced by aluminium 2 oxide 3, boron 2 oxide 3, phosphorus 2 oxide 5. General properties of glass. On this picture you can see a crystalline of quartz, silica, and amorphous of silica. Silica and oxygenium. So this is a quartz, this is a glass. So general properties of glass include amorphous solid, amorphous solid. No definite melting point. Very brittle material. Softens of heating. Can absorb, reflect, and transmit light. Has a good electrical insulator. Affected by alkalis. Not affected by air, water, acid or chemical reagents. Possesses high compressive strength and since it doesn't have any crystalline structure, no slippage between planes can occur. Light invades because it has homogeneous internal structure similar to liquids. The raw materials for making flat glass would be as follows. Sand, sodium, limestone, dolomite, mixture of calcium, carbon and magnesium, carbon. Feldspar contains potassium, sodium, aluminium, silicon, and oxygen, of course, sodium sulfate, and cooled, broken or scraped glass. So, glass components: sodium, potassium, calcium, barium, and silica, and of course some other. The raw materials are put into a furnace and heated until they have fused to form a glassy mass of material. This material can then be fed into the appropriate process. For the manufacture of flat glass, glass fibers, both short and long, glass wool or matting for insulation, light bulbs, containers such as bottle and jars, etc. Technological advances have changed the market for glass products quite dramatically over recent years. For example, much glass was used in the manufacture of cathode ray tube envelopes for use in television sets, computer monitors, oscilloscope, etc. Flat screen technology and high speed, analog to digital conversion devices have rendered the cathode ray tube obsolete. Polymeric materials have taken other markets for transparent materials. Aircraft windows are made from perspex that include polymethyl methacrylate because it's significantly lighter in weight than glass. In situations requiring high security, such as for glazing in banks, transparent forms of polycarbonates are now used because they have higher fracture toughness than glass. Now I would like show for you name of the elements. Sodium, potassium, calcium. Source of the element of sodium, natrium and carbonate and natrium and sulfate. Potassium, source of the element kalium, carbonate and of course hard glass. And calcium, so from calcium you can receive a glass with high strength and Ri. Barium, name of the glass produced, glass with high Ri. Lead, source of the element litharge. Red lead, name of the glass produced, flint glass. Zinc, source of the element zinc oxide and glass produced, heat and shock proof glass. Borate, from borax boric acid and product heat and shock proof glass. Silica you can find in sand and quartz, colors yellow in ferric salt, green in ferrous and chromium, and blue in cobalt salt. And you must understand that copper is a metal of strategic importance, and it's also expensive and in short supply. Many years ago, electrically controlled servo motors replaced metal cables, levers and bell cranks for the control of aircraft in flight. Optoelectronic devices have now replaced many electrical systems, thus obviating the need to copper wiring to connect the servo motor to the flight controls. Glass fibers are lighter and cheaper than copper wires, and the signals transmitted consist of light pulses instead of pulses of electricity. Since we are considering materials for construction, we shall consider flat glass, glass fibers and glass matting for insulation here. And how glass manufacturing? Very interesting and useful process. Manufacture of glass consists of the following high-level steps. Melting. Fine-grained ingredients closely controlled for quality are mixed to make a batch which flows into the furnace, which is heated up in up to 1500 degrees Celsius. This temperature is the melting point of glass. The raw materials that float glass is made up of acetic acid, sodium oxide from soda, calcium oxide from limestone or dolomite and feldspar. The above raw material, primarily mixed in a batch, helps to make clear glass. If certain metal oxides are mixed to this batch, they impart colors to the glass, giving it a body tint. Melting in a pot furnace or tank furnace can be. Apart from the above basic raw material, broken glass alkylate is added to the mixture to the tune of nearly 25%, which acts primarily as flux. The flux in a batch helps in reducing the melting point of the batch, thus reducing the energy consumed to carry out the process. Next step is forming and shaping. Glass from the furnace gently flows over the refractory spot of the mirror on the mirror-like surface of molten tin, starting at 1100 degrees Celsius and leaving the float base a solid ribbon at 600 degrees Celsius, and then coating for making reflective glasses. Coatings that make profound changes in optical properties can be applied by advanced high-temperature technology to the cooling ribbon of glass. And then the next step, annealing. Despite the trans quality with which the glass is formed, considerable stresses are developed in the ribbon as the glass cools. The glass is made to move through the annealing lathe where such internal stresses are removed, as the glass is cooled gradually to make the glass more prone to cutting. At the finish, to perform the inspection and cutting to order. To ensure the highest quality, glass manufacturers carry out inspection at every stages. And the entire process of Glassmaking is finally complete when diamond steels trim off selvage, stressed edges, and cut ribbon to size dictated by the computer. Glass is finally sold only in square meters. Melting. Raw materials in proper proportion: sand, soda, ash, and limestone are mixed and finally poured. The homogeneous mixture, known as batch, is fused with some broken glass called cult in any of the two types of furnace. The homogeneous mixture is melted either in pot furnace or tank furnace. The batch melts and fuses at 1800 degrees. And figure shown pot furnaces, hot gases and hot airs. And two types of pots are used: open crucible type pot and closed covered type pot. Generally, closed covered type pot is used.